An important aspect of the security of LTE is the concept of a key hierarchy. Let's see what the key hierarchy is, and also try to understand why there is a key hierarchy in LTE, or the Evolved Packet System. So at the top of the key hierarchy is the master key K that is stored in the HSS, and actually it is stored as part of what's called the Authentication Center, AUC, which is the secure part, or even the kind of vault sitting in the in a bank, like in an HSS. And similarly, the master key K is stored inside the SIM on the mobile, inside the SIM, and you cannot actually access the K key through any commands that are provided to an end user. So you as an end user cannot go in and find out what your key is. Actually, you need specialized software to read the master key from the SIM card. So this is the most secure, and you need to make sure that the key K is kept secured, because if the key is compromised, essentially the identity is compromised, and anybody else who owns this key can fake the identity to the network. So from this K key, what's derived is the CK and IK, as we had covered in the previous slide there, which is then provided to the mobile equipment. So what comes out of the AUC is the CK and IK, which is the next level in the hierarchy down. And one of the things you can see here is that the CK and IK was actually created based on the K key, the random number R, or RAND, and also the sequence number SQN. So if the CK and IK which is in the mobile, if this is compromised, if somebody gets hold of this, the master key is still not compromised. So the reason for the hierarchy is that if a key at a lower level in the hierarchy is compromised, it's still not a problem, because you are still saving the key at a higher level in the hierarchy. And that's one of the reasons why why there are multiple keys that are being created, and there is a hierarchy. So based from the CK and IK key, you would get the next key, which is the KASME, and this is the key that is provided to the MME for deriving further keys. And here again, MME is further away from HSS, from a trust model. So if you go in and hack in, and you're able to get access to the KSME, so that this is no longer secure, still the CK and IK and upper layer keys are still secure, even though KSME has been hacked. Similarly, on the mobile side, from the CK and IK, the KASME is derived. And from the KASME gets derived what are the ciphering key and integrity protection key for the NAS layer, for the NAS communication, non-access stratum messages between the mobile and the MME. From the KSME further, what's derived is the KE node B, which the MME provides to the E node B, and it is independently from the KSME. The KE node B gets derived on the mobile side using the same algorithms that MME is using. And the KE node B is used to derive the ciphering and the integrity protection keys for the access stratum, which are used for encrypting and integrity protecting the signaling radio bearers. So now we have the CK and IK for the RRC. We also had said in the previous slides that we have encryption for the data radio bearers, or the user plane. So the CK for the user plane is derived from the KE node B, and used between the mobile and the E node B. There is another key which is called the next hop key, which is again derived from the KSME, both on the network side and on the UE. And this next hop key is used for creating keys for changing the key and creating a new key when the mobile hands over from an old E node B to a new E node B. So every time the mobile changes a base station, the key gets changed, and the key is changed in such a way that the old E node B is not doesn't know what, cannot derive the key that is being used in the new E node B. So if you do hack into one E node B, once the mobile hands over to another E node B, you cannot get access to the signaling to the SRBs or the DRBs that are being used. You cannot decipher those based on the KE node B that you have over here. There are we would look into, when we look into the handover flows, we will look into how some of this derivation of the keys into the new E node B happens. There's also one of the things to keep in mind is that the keys for, typically a base station has three sectors. I mean, it is serving three sectors. Whenever a mobile kind of even changes from one sector to another, the E node B, the keys get changed even on a handover if the mobile goes from one sector to the other. Once a mobile goes into another E node B, obviously, which is having another three sectors, obviously the key gets changed also based on this key. So every time there is any handover which is either intra E node B handover or a handover from one E node B to another, the keys are changing. The keys change based on the next hotkey only when you do a handover from one base station to the other, and there are certain details that we would have to go into for handover key changes that we will cover in the handover security slides that we have coming up. So this is the high level key hierarchy that you would see, and as we had said before, the idea of this key hierarchy is to make sure that keys at a lower level that do get compromised do not lead to a compromise of a key at the higher level, right?